Action.
All right, welcome to class, everybody. So I've had the bell work up on the board. Last time we talked about the Cuban Missile Crisis. Do you guys remember this?
Yeah.
Yes, awesome. Okay, so you're gonna write, well, by this point you should have written one paragraph about what the Cuban Missile Crisis was. How did President Kennedy respond to the Soviet presence in Cuba? So this is also a big deal because I want to get the point across about the Cold War and how intense the Cold War really was. Like, this was a really, really tense time. And there was intense competition. We had to prove that we were better than the Soviet Union. We could not let them get ahead of us. So once the Cuban Missile Crisis had all been resolved, like we talked about yesterday, still there was that competition going on with the Soviet Union. Do you guys remember what the main biggest country was in the Soviet Union?
Russia.
Russia, yes. And the USSR is what the Soviet Union is called overall. So awesome. Okay.
Wait,
The Soviet Union.
Yeah.
didn't the Soviet Union like separate? Is it like different now?
Yeah, that's exactly right. So
consisted
it
of
did
15
separate into separate countries. And that was, do you guys remember 1990, 1991?
It was 1991.
About,
It was-
around
it
that
was
time?
December.
Yes.
Right, yeah, thanks guys.
I think it was, I believe it was the 31st.
Okay.
December.
So, and yeah, now they're all separate countries. So now there's something else I want to ask you guys about. With that competition and the Cold War and all of that, like, we started going to, like, the space race really started heating up. Like, we started competing with the Soviet Union for bigger and better things in going to space. But something happened recently that has nothing to do with the Soviet Union, but it reminds us of the space race back then. So do you guys remember what happened having to do with NASA on April 21st? No, April 1st, sorry. What happened on April 1st? Do you guys remember?
Artemis 2 went around the moon.
Yes, Artemis 2 went around the moon, exactly. So, these are real pictures, and this is a picture taken of Earth from the Artemis 2 mission. Now, what about Artemis 1? Like, why is it Artemis 2, not Artemis 1?
Because Artemis 1 was like to test the rocket and stuff.
Artemis 1 was to test the rocket, exactly, yeah. And that's the way that NASA has always done it, lots of tests. Do you guys remember which of the moon missions landed on the moon, and which moon mission was it that Neil Armstrong came out of and, you know,
Apollo
walked
13.
on the moon for the first time? Say it again.
Apollo 13.
No, you're close
Oh,
though.
Apollo 11, my bad.
Yes, Apollo 11, yeah. Yep.
That's okay.
All right, so, but that was Apollo 11. And what about Apollo 1 through 10? So, yeah, Ethan. Oh,
Well,
yeah.
I know the first Apollo, it like exploded because didn't it?
One of the early ones did during, yeah.
Because they put like 100% oxygen, and
Yep.
that doesn't like and it exploded because like humans can't have 100% oxygen.
Yeah, you're absolutely right. And
It has
so
to like be mixed. Everything.
it has to, yeah, otherwise it's highly flammable. And that was a very dangerous situation. But NASA learned from that. And that kind of goes to the point that I want to make with you guys, that testing is super important. So they learned from that mistake what not to do the next time. And so there was Apollo 1 through 10, those were all test runs at various phases of the Apollo missions. Until finally, they felt like they had it right and they could land the astronauts on the moon with Apollo 11. So, yeah.
Then what happened to Apollo 12? Was there one of that?
You know what? Apollo 11 through 17, most of those were successful and landed on the moon. I know Apollo 13 famously did not work out. Like they had problems with the capsule, and they were not able to land on the moon. And fortunately, they came back safely. There's a really good movie about that. Apollo 12, as far as I know, it was another safe and successful mission, but Apollo 13 was not. So I want to show you guys just some of the process that NASA went through. And like testing. It's all about testing until you get it right, so that humans don't get hurt in this process. And of course, from time to time, like you were saying, they do get hurt. But like they started out, the very earliest rocket tests were the Vanguard rocket tests. And they went through dozens of these before they finally got some to launch properly. Do you guys, were you around when SpaceX was first starting to do their rocket launches? And this is more of a recent thing, the private company SpaceX.
Yeah.
They went through dozens, I think even possibly hundreds of test rockets before they finally got it right. And that's what NASA kind of went through as well. They started with the Vanguard rockets and just kept testing until they got it exactly perfect. Yeah.
This one time, like a few years ago, I looked in the sky and like I saw like a SpaceX site.
Yeah, that's cool. So just a few weeks ago, I actually saw one of the SpaceX things in the sky, the boosters,
Yeah.
and I wasn't sure what it was, and so
I didn't know what it was either.
yeah, I posted online about it, and I was like, what did I just see? Did I see a comet or something like that?
That's what I thought it was. I thought
and
it was
then-
aliens.
Yeah, right. And one of my older brothers actually pointed out, he was like, yeah, there was a SpaceX launch. That's what that was. Do you guys have a question?
Can I hold on to you?
Yeah, sure. So on October 1st, 1957, this was one of the first really successful space launches. However, well, there's a catch to this. So this is Sputnik. What can you guys tell me about Sputnik?
It was the first satellite ever sent into space.
The first satellite ever sent into space, exactly. And who launched it?
USSR.
Yeah, the Soviet Union, or Russia, yeah. And this was an embarrassment for the United States. Like, it showed that they were more advanced. If they were able to send a satellite up, like, man, they were ahead of us in this. But some cool things did happen, like our government, or really NASA, or what would become NASA, they were actually able to listen to the radio signal that it put off. They found the frequency and were able to listen to Sputnik. So they actually confirmed that it was up there. Our government did. And a lot of Americans got really nervous about Sputnik. Like, they were afraid that the Russians were gonna use it to spy on us and things. And the President of the United States had to assure the public, and Harry Truman had to assure the public, no, everything's fine, we're safe. This cannot be used to spy on us. They're not that advanced. But this did show that we needed to step up our game as a country. Okay, then, so we started our first flights, or our first missions that we sent up into space were really just one-man capsules sent up to orbit the Earth. And this was called the Project Mercury, or the Mercury space flights. This is kind of cool. This is actually at the Smithsonian Museum in Washington, D.C., so you can actually see these early capsules. Yeah?
Do they still make one-person capsules?
No, they don't. They don't. In fact, well, we'll talk more about the ones that they do now, but now they hold, like, I think it's 5 people, the capsules. So. Now, I actually have a stuffed animal of Ham the chimpanzee, and so I have my own little Ham. And
Oh, yeah.
Yeah, I brought it to class another time.
Oh,
And he's dressed in a spacesuit. I thought it was, but one great thing about the animals that the United States sent up, they came back. So the Soviet Union, when they were doing testing and sending up animals to see how living things handled space, they weren't able to bring them back. So, you know, go USA. Yeah, it's pretty awesome for us. that we
USA
can do
cares
that.
for the animals.
Yep. And the early Mercury astronauts, like, these guys were heroes. Like, they became rock stars, practically. We don't need to go through each of their names, but these guys, they were in the news back then. Like, everyone knew who they were. Everyone knew who they were. In fact, like, they had special deals, promotional deals with private companies. And this continued even into the Apollo missions and later. Like, Corvette, the car, Corvette actually gave all of the astronauts free Corvettes.
No.
So that they would, and actually I think they charged them like $8 each or something like that. But they did that so that the astronauts would be seen driving Corvettes because it made Corvettes look more cool. And then NASA was also able to raise money by partnering with other organizations. Like there's a powdered orange drink called Tang. Have you guys ever had Tang?
I've heard of it,
Okay.
but no.
Yeah, it's just a powdered orange drink that you add to water. And so they partnered with Tang, and then Tang was able to say, hey, this is the drink that the astronauts drink. And that was really awesome. So then everyone wanted Tang. Yeah.
Is it similar to condensed orange juice?
To a dense orange juice?
Condensed.
Oh, condensed orange juice. No, it's more like Gatorade powder or something like that. Like,
Oh, okay.
I mean, it tastes very artificial. Yeah. So the first human in space, the Russians beat us to it again. Yuri Gagarin, this is the first human being to go into space. That's a big deal. And yeah, this made like worldwide news that Yuri Gagarin went into space. Alan Shepard was the first American to go to space. And he orbited the Earth, orbited a few times before coming back. Okay, now let's watch this famous speech that President Kennedy gave about why we needed to step it up and why we needed to go to the moon. This is super famous. Yeah,
I've seen this.
yeah,
Have you showed us this one before?
I think so.
There is no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to us all. Its conquest deserves the best of all mankind. And its opportunity for peaceful cooperation may never come again. But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge...
Not because they're easy, but because they're hard. What do you guys think of that speech? What are your thoughts?
It's pretty like inspirational.
Pretty darn inspirational, right?
That they can do hard things, overcome challenges.
Say it again.
What was his name? Thomas or
Kennedy?
John Kennedy. They wanted to inspire them and prove that they can do hard things. Like not just like really easy things.
Yeah. Wanted to prove that we could do hard things. You know, something else about this, you guys. The budget that NASA has now is 5% of what, when you adjust it for inflation, 5% of what it was in the 1960s. So the United States government spent a fortune, like many billions of dollars, trying to win the space race, trying to beat the Russians.
5%.
It is 5% of what it was. Yeah, that's adjusted for inflation, but it's pretty incredible.
Mr. Britsch,
Yeah.
you know for this Apollo 11 mission how like Neil Armstrong said, one small step for man, one giant leap for mankind?
That's it. Yeah.
Like he had that like ready before because he was the first person to step out, but then Buzz Aldrin didn't know what to say because he didn't have it prepared. So he just said something.
Neil Armstrong knew what to say, I guess. That's interesting. Yeah.
I'll say it later.
Okay. So let's watch the famous Apollo 11 moon landing, and then we'll talk about the actual rockets that they went up on and how they functioned, how that worked. I'm gonna fast forward just a little. That's probably good.
Tranquility Base here. The Eagle has landed. Rocket Tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Okay, here we can see you coming down the ladder now. At the foot of the ladder, the limb footprints are only impressed in the surface about 1 or 2 inches. And they'll step off the limb now. It's 1 full step for man, 1 giant leap for mankind.
One small step for man, one giant leap for mankind. What do you guys think that means?
It's a huge advancement.
It's a huge advancement. Yeah, exactly.
It was like a really big accomplishment and like something that like the whole world would be proud of.
Yeah, absolutely. Absolutely. Yeah.
Yeah, I remember now. I was gonna say that it's crazy that now we only have 5% of the budget. And then,
Yeah, it's kind of insane. And yet we're going back to the moon. I mean,
yeah,
it's pretty
5%
incredible.
of the budget that NASA once had, and we're getting like rovers and stuff to Mars.
Yeah, yeah.
Oh yeah.
Do you have a comment?
Yeah, I searched it up what he said, and he said magnificent desolation.
Interesting. Magnificent desolation.
Because
Okay.
he didn't know what to say.
So I had the opportunity to go and see a Saturn V rocket in Houston, and like they have one there, and it's incredible. I mean, it's like several football fields long, and they had it laid out on its side, kind of like this model of one that I have here on the table. Just walking around it, walking from the front all the way to the back, it takes several minutes to walk all the way around. And so what I want to show you guys, I'm going to actually use this model to demonstrate exactly how this process worked. So this is a Lego set. It comes apart really easily. It's also really fragile. But the part where the astronauts actually sat would be up here. This is the capsule. So that gives you an idea of the scale. The capsule is just this tiny part here at the top. And so it would launch and it would drop off stages as it went. Why would they do it that way? What are your thoughts?
Less weight, so it's easier to get out of the atmosphere.
Yeah, to lose weight so it's easier to get out of the atmosphere. Yeah,
Once you burn the fuel, you don't need the fuel tanks anymore.
exactly. Now there's an equation that NASA has to figure out. So you need fuel in order to get it into space, and a lot of fuel. The more fuel that you have, the heavier it gets, so you need more fuel. Does that make sense?
Yeah. And it's
So,
kind of a paradox.
Now, in the early days, in the 1960s, they had to hire professional mathematicians, like the women from the movie Hidden Figures, like that's a true story, to figure these things out. Now, thank heavens, we have computers that can figure these things out a lot easier, that can do these formulas and things. But yeah, it would launch, it would start, and then, let's see. Oh, and it's caught on camera.
No.
It's okay. They're Legos. It's rebuildable. Anyway, I don't think it's too bad. Hey, could you pause it?
Yeah.
Thank you.
Are you ready?
All right, we got this put back together. Here we go. So, this part would drop off, fall away. Set that aside. And then it would keep going, and then this part would drop off and fall away. Finally, then we get into outer space, and even from here, it gets a little tricky. At this point, once it gets close to the moon, then it opens up, and the actual lander comes out. I'm gonna set this aside, and let's see. Then the little capsule part here, and I should have another little capsule part. Okay. So now this is actually the one that would float in the ocean like after it lands, but we're just gonna use it for this example. So we're gonna pretend that this is this top cone part here. This is the lunar lander, and this is the actual capsule. These would join up like this, and then they'd orbit the moon. This part would land on the moon. This part would stay in space. Okay, and then I have an example here of a bigger version of the lunar lander. Now with this, let's scoot this stuff aside. Then Neil Armstrong would come down the ladder right here. Come on down the ladder, and then once they're done with all their exploring and all the stuff they do on the moon, then it would take off. Leave this bottom part on the ground. This would go back into orbit around the moon, and the top part of this would join back up with the capsule, and then they'd go home. And they would be inside this part. Now, what was it you were showing me, guys? Okay. All right, so let's keep going.
The Apollo's.
Okay, just moving ahead a little bit. Now, we're onto the Artemis moon missions. So, let's go ahead and let him back in, that's fine. Okay. So, this is an actual shot that was taken recently, just a few weeks ago, by the Artemis missions. And the Artemis missions work in a very similar way as the Saturn V rocket. So the fuel tanks are down below. This has these booster rockets, but the capsule is up in the top where they sit, and it has, well, the other parts of the spacecraft in there. It's a very similar kind of thing as what they did with the Saturn V rocket and the Apollo moon missions. So, you know what we'll do? I'll let you guys take a look at these in just a minute once we're off camera. And I also have a handout. I'll go through the handout with all of you. It has a letter written by a little girl to President Kennedy about what's happening with the moon missions. So we'll take a look at that. We'll go through each of the questions, and then I'll give you time to work on that on your own. All right. So now we'll end by just going through this a little bit more, just showing how the Artemis missions are very similar with multiple trials. In this case, going all the way around the moon. And there we go. All right, thanks you guys. Okay, you can go ahead and stop it.